Good afternoon. My name is Gabriela. You can find me on Twitter at Gabi. Again, I'm Gabriela, but I prefer to go by Gabi. It's easier, so nobody has trouble misspelling the L's and stuff like that. I'm a developer advocate at Google, which means I travel a lot, and they pay me to talk to people, which is nice, and to teach people how to use Google's technologies, but also other technologies. I am very inserted on the MySQL and PHP community, and although it's Oracle's technology, there's a drama there, but let's not talk about that. And that starts. So MySQL, it's currently on the version 8.0.11. The thing is, the version before that, the release candidate was 8.0.4. They skipped, again, 7 numbers and put it in 8.0.11. And are we there yet about this talk? It's like, we always have this inferiority syndrome, like because we use MySQL, it's not a good enough database to do stuff. You start doing your MySQL, then you change to Postgres because you're gonna have more features there. And I can't argue, Postgres is great for a lot of stuff, but MySQL is getting there, is getting a lot of new cool features and allowing the growth of a lot of companies to be successful because of it. So when it was created to handle small cases from 10 million to 100 million rows of data or 100 megabytes per table. Now it supports terabyte-sized databases. On our managed service on Google, we support up to 10 terabytes on your database, on a single database. And supports SQL standards as new as SQL 2016 with the JSON RFC, so we support JSON. But however, some stuff is still from 2003, just got implemented, like window functions and CTEs. Now, what can we go from here? What can we grow out? MySQL can grow and learn from other databases. There is one feature, I don't know who uses Postgres here, but it's called partial index or conditional index. You can create an index on the database conditionally. Like I only index these values if they are higher than 11, for instance. That's a cool feature that's going to be used for a lot of cases. But let's hope that in the future they just copy that up. So what happened to 6 and 7? Maybe they got inspired by a language and skipped versions, but as far as I know, they had their enterprise product called the NDB cluster, and the NDB cluster had a version 6 and had a version 7. And with the version 8, they are unifying all the versions together of the NDB cluster with the MySQL community version. So that's why it goes straight from 5.7 to 8. The topics of this talk is going to be new defaults and variables. I'm going to talk about InnoDB performance. What are window functions and common table expressions? And in the end, I have a tiny bit of new features that are inserted in the new version. So the new defaults and variables, it's who here had trouble with shortset? Like everybody. Yeah. So good news is on 5.7 you had Latin 1, Swedish case insensitive, if I recall correctly. And now it's 8.0, it's UTF-8 and before, which means that's 4 bytes per character on the UTF-8 format. And it means that you can have mathematical equations, emojis, and even languages that you don't even think that exists, and like transcripts, historic transcripts inserted on the database without any issue. So the shortset defines how the data is going to be stored, while the collation defines how the data is going to be compared. And the default collation now, it's this ugly thing, and it just means you have 9.0 support for UTF-8, and I know that it's on 10 right now with F8 or 11 already, but when they started the development of MySQL 8, 9 was the most recent one that they had. Accent insensitive and case insensitive. There was a bug before UTF-8 and before you can use on 5.7, but if you use one of these two collations here, you could have a bug where if you use the sushi emoji and the beer emoji, they are equals. They're considered equals. So we don't have that bug anymore. Other default variables, binary logging is enabled by default. So if you need to do a point-in-time recovery or go back in time or do replication, it's kind of already setting up for you. There is a new plugin authentication. It doesn't use uses SHA-2 using SSL certificates, and it's more secure way of accessing your database through a new layer of security, but you still can use the old way for authentication purposes if you still need it. There is mandatory default value now for timestamp. For instance, you could create a table, timestamp default empty, but say that's not null, and then before it would insert zeros as a timestamp, or a date, or 0 also as a date. Now it gives you an error, and you need to have a default if you're using not null. And there is a new variable. If you have a dedicated server, you don't need to figure out how to configure the buffer size, the log file, the flush method. You just say that's a dedicated server, and all these variables are gonna get configured dynamically for you on the MySQL configuration file. There is a new thing that MySQL is doing that no other database in the world is doing, and it's regarding to InnoDB. It's transaction scheduling, as we call. It's a new algorithm that they're using based on, I forgot the college, but based on a paper, a professor and their mentee came up with the paper and they implemented it on MySQL. So routinely, you have a database and you usually have a first in, first out transaction architecture. So transaction B is only going to happen if transaction A happens, and B only happens if after A, and C only after B, and that's start to finish. That's usually first in, first out normal transaction for databases. Now they are using CATS, what they call. CATS stands for Contention-Aware Transaction Scheduling. It's a big name. And I'm sorry for my drawing. I try to illustrate what's going on. But now, the best analogy that I have, it's like, I'm gonna assume that most people knows how an airport works. And you have in the US, you have TSA where you need to go through security. And every plane is has a gate that's assigned to it. If everybody takes too long to take on the plane, the gate's not free, so no one else can use the gate, so no other passengers can come, no other flights can go. That's more or less what's happening here. So MySQL is taking care of the process of receiving people and administering the gates, so you can have the most amount of gates free, let's say, so most planes can come and go faster. That's the best analogy. It doesn't matter who came first or not. It's gonna figure out based on the algorithm that they developed which transaction gets to execute first, and it doesn't mean it's in necessarily the same order. So that's the performance only changes after 30. It starts to kick in on 32 transactions per second, and you see that on CATS, the higher is the better. So you can have more clients, and on FIFO you only have like a third of it or something like it. And the same thing is regarding latency, because depending on how many transactions you're having on your database, the more time it is going to take to respond to you. And the latency here is way lower, 5 times lower on the new algorithm that they are using on MySQL 8. So if you have like a high throughput, highly accessed database, that's going to kick in and it's going to make things faster without having to scale vertically your database. Indexes, this one makes me happy. Who here had to create an index and took hours and hours and hours to do it? Everybody. So I have an example. I went to, I don't know if you know Kaggle, Kaggle.com. It has like a lot of open data. So I got all the Simpsons lines of all the episodes. And I decided to play around with that, to play with the indexes. So I have ID, I have number, and like other fields, and I'm gonna play with word count. I'm gonna create what we call invisible indexes. And like, why the hell do I want an invisible index, you're gonna ask? Well, let's say there is a problem with indexes that you can have too many or you can have too few. If you have too many, the writes are really slow. And if you have too few, the reads are really slow. So if you have too many writes, you may want to see, like, disable that index to see if the performance got better on your writes, and then drop it because it's a operation that takes hours to be performed. It's a copy operation where it copies the whole table to do everything again. So it's not used by the optimizer, the invisible indexes. It's visible by default when you create an index, but to create the invisible index, you just add the word invisible in the end. And you can toggle the visibility on and off. And those operations to toggle the visibility on and off are quite fast. It doesn't take milliseconds at most. And that, it's an example that I have here, selecting all the lines where the word count is higher than 25. That's the query planner for with the index. The index exists, but it is invisible. And it's scanning 135,000 rows, or what I mean, the full table. But when the index goes back on, I only scan 6,000 rows because I have an index on the word count. So you could see, like, is this index being used or not? There was cases where the performance could go worse or not. And that's when you toggle visibility on and off to know what you're going to do. This one is what makes me happy, that has been like a complaint that I have been doing since 2015 for the Oracle Developer Advocate. I was like, we don't have descending indexes because up to 5.7, the syntax of 5.7 allowed you to have ascending or descending when creating, but the documentation says that in future extensions are being implemented and they are currently parsed, but they're ignored. So you could put descending there. It was not gonna work. It took me days to figure that out. When I first started using MySQL, for me, I was like, what the hell, that's descending is not working. And that's why, because it was not implemented. Now we have it, which is good. And the thing with descending indexes is it works backwards too. It's no longer ignored and forcibly created as ascending. So you can use the same syntax that they would ask you to use before, but they would ignore. And the same syntax of, I created this index as descending, the index word count. And if you look at the query planner for the descending order by or ascending order by, they're going to have the same cost. So let me show you here. So that's my table lines. I don't have the index here. So I'm going to alter table lines, word count. And it's there. If we look again, I have the index here. So let me get that query. Select star from lines, where word count higher than 25. Order by word count. This one, I created the index ascending. So I'm going to run the query first with the ascending query. And then let me put an explain in here. You see that here it's using the key that I just created, and it's filtering 6,000 rows and 100% of it. And what you want you to pay attention to is this thing here, the extra, using index condition. Now, if you change to descending, it still uses the index, but it says here, backward index scan. What it means, it's not, before it would do a full table scan to get descending. Now it just uses the index you already have, no matter if it is ascending or descending. So you don't have to create two types of indexes on your database if you're doing the two types of queries. There's more cool features. Window functions, who here knows what they are? So window functions are also known as analytical functions. They are used on what we call mostly OLAP databases like Redshift and BigQuery. OLAP stands for Online Analytical Processing. And usually they are slow processing. You use aggregations and that kind of stuff. And window functions is present on Postgres, for instance, and now it's present on MySQL 8.0. So what they do, they allow you to analyze, you have a result from a select, and you will be able to analyze the result with the rows that you have in hand. You cannot change the result. You can look at neighboring rows. I can look at the row that was before me and the row that's after me and know that information, do something with it. And to do that, you need to use we call a frame. It's like when you're looking outside a window and you change angles, you're changing your framing, and you're looking over something. And that's when you do a partition of a window. And the partition behaves like a group by. It's not a group by, but it kind of simulates a group by itself. So examples of window functions, you can add a row number. You can use the sum and get accumulated sum of how many million viewers there were per episode and season. Rank results and look, as I said before, as the neighboring rows with lead and lag. So this is also from The Simpsons. It's an episodes table, and I'm gonna be playing with the episode date and million viewers here. Don't need to figure that out here. So the episode date for now is just a simple select, bringing the first 10 episodes. And if I want to get the previous episode and the next episode of that query here, so I want to get the previous, that's the date of the previous, that's ID 1, and the next one that's from ID 2. You use the lead and the lag. You put up the framing, which it is the order by episode date, because the order in this case is important. I need to know which episode was before. And the same thing with that, with lead, the order by episode date also. When you look at that, that's what you get as a result. You get the previous episode and the next episode as columns. The results set did not change. It did not change what the query is bringing to you. It just added those columns with the information that you already had on the results set. So if you look at the color scheme that I created there, you're gonna see that the current episode date for number 2, which is red, is actually the next episode date on the first one. So you have access through all of the results from your result set with episode date. The breakdown is lag is a function, episode date's the column that you're getting the information that you want to know what it's about, how many rows preceding the partitioning I want, and that the window that you define with order by in this case here. But we are developers, we like Jai. We like to keep things simple as possible. And we are repeating here ourselves. You're doing order by episode date twice, And what happens if I do it again? I need to copy again? No, you don't need that. You have named windows. You can add a name for a window. I named mine dates. And I'm just saying, hey, use dates here. And if I change the definition of dates, it's going to automatically update the query here without having to change everywhere else in the query. So I have an example here that I want to show you. So this is the query that we just ran. I just have a different name for the window here. I'm calling W episode date, but it's the same query. And if I run, I get the same result set that I was just showing you all. What I want now, I'm going to add it here. I want to use the rank function to know what is the order. Like I have a season, and those episodes, which ones are the most viewed? I want you to rank for me which one was the first, which one was the second most viewed, and so on, so on. So you rank over, and remember that I say the partition by is like a group by. Since it's by season, I can do a partition by season. And the order is important because I want to know which one had the most million viewers. So order by million viewers, descending. And let me give you this a name. And let me show you here. So for the first season here, season 1, the 9th episode of the season was the most viewed. The second one was the 11th. And there is a catch here. You're going to see the 9 repeats twice. That's okay, 2 million same amount of million viewers. But then skips to 11. It doesn't have the 10. It's just because since there's 2 ways of doing ranking, and to solve that problem, you just use dense rank. And it's going to fix it, and the 10 is there, and then the 11th. I could do also the accumulated part of how much million viewers were watching on every season. So I want to partition by season again. That's a big thing. Don't worry about it. I hope it works. So this is cumulative. If you see here, the first one has 33 million, and then the second one is the sum of the first with the second, and the third one is the sum of the first 2. That's useful for analytical reports where you're getting like the accumulated amount, like a shopping cart, or how many value you're generating on your e-commerce, for instance. So that's one way of using window functions to get accumulated results. And if you get to season 2, it resets again, because I said it was by season. Common table expressions are, most people think it's just synthetic sugar for subqueries. Instead, like, the problem of using subqueries is because you wrote once. If you needed to use it again, you need to write again. And common table expression allows you to create something like a temporary table, but it's not a temporary table because you don't need a create privilege to use it. And you can reference other table expressions or reference itself because it can be recursive also. And it's easier to read, way more easier to read. So this is the ranked episodes of the query that I just did before. It's the same query. And I'm going to show you a filter. Let's say I want to get only the first. So I have all the rankings here, but I want to, not the first. The first, we could say you could use limit 1 and on the subquery. I want all the 5th most watched episodes. So normally someone would get a query here. and do something like this. Where ranking, in this case, I'm going to put equal to 5. So everyone that's seen here on my results set has a ranking of 5. But if you look here, it's not easy to read at all. It gets bigger and bigger if you have more subqueries to be doing inner joins and that kind of stuff. So there is a special word called with, and you give it the name. In this case, I'm doing ranked episodes. And you define how that table expression is going to look like. It's like a view, but not necessarily. So that's our table expression. And if you want to use it, if you want to see, you just do, in the end, the new table you just created. That's bringing everybody in here, where ranking equal to 5 again. And if you need to do inner joins in here, you can do inner joins. You can create multiple table expressions with the same width and one referencing the other. So that kind of saves time instead of having those huge blocks of SQL queries to be maintained. It's easier to maintain. There is also Recursive City, and this is the part that I hope I don't lose my job, because I'm going to try to do Fibonacci using SQL queries. So I don't know if it's going to work, but let's see. So the recipe is the base query comes first. It's like when you do recursive functions, your base case is where do I start? And then in the case of the query, you need to continue to get all the other information, which it is with a union. And the stop condition, which will stop the recursion itself. So it's kind of a function on PHP, for instance. So I'm going to open here. So I put the steps in here. So I kind of cheated a bit. You still use the with, but you say the recursive port and the name of the expression, of the table that you're creating. And in this case, it can receive, like, it's not parameters, but it looks like it. And again, you use the as to do the definition. And now my second step is the simple case. What is the simple case of Fibonacci? Starting with 1, right? So I do select 1. I'm going to actually use recursion 11. I'm going to start with 0 as a recursion 11 starting at 0. My first Fibonacci number is going to be 1. My next number is 1. And the sequence I'm going to cast as a string here, because else it's going to blow up on your minds. So this is just, if I select here, it's just a simple row. Now, where the recursion comes from, when you do the union all, you select, and what is the next recursion 11? Is going to be recursion 11 level plus 1. Then the Fibonacci number starts to be the next number because I'm changing rows. And Fibonacci sums the current number plus the previous. So I'll have Fibonacci number plus next number. And I'm just concatenating here so we can see what it's going to look like. Sequence with next number. But I created all the select. That's what's going to happen. Recursion 0 level 0, 1. So this is going to be returning 1. Next number is 1 because it's what I defining here. Fibonacci number is going to be the current Fibonacci number plus the next number, which is going to be 2. The next number is going to be 2. And the concatenation here, I'm going to bring 1, 1, 2, and so on, so on. But all of that comes from Fibonacci itself. And then our stopping condition, where I'm going to put recursion level lesser than 10. And in the end, remember, it's a common table expression. You declare it, but you need to use it. So you need to just select star from Fibonacci. And it should work. Let's see. Let's go. It's here. I put it everything. So this is the Fibonacci number currently, and the next number is going to be 144. And if you don't set up a recursion level, an error will occur. Data too long, because I limited the short for 255. But that's it for Fibonacci. How I am in time. Okay, that's the query in the end that I created. And this is the recursion call. So it's the same query, it's going to be the slides. And this is useful when you have, for instance, WordPress, where you have categories that have subcategories. And it's a hierarchical data, and you want to go through all of that. So instead of doing a loop on your PHP code, you can do a loop, whatever, inside the database already, instead of going through the code to get all of that information of who's parents of whom. And that's the base case as the first line, and the recursive query generated all the other ones. Other bits to finish. MySQL 8 has a data dictionary now, which I have something here. Ignore that. The data dictionary and atomic DDL. So before, the data was stored on my JSON tables, and they were prone to corruption and getting problems with synchronization between replications. So all that text file structure that MySQL had before, it doesn't exist anymore. Everything now is inside InnoDB tables, and they are, since InnoDB is transactionable, you can do atomic DDL that we call. All of the data is accessible through the information schema, which are views on the data dictionary. And I see that some people access the performance schema to know how many rows a big table has. And instead of that kind of operation now is going to be 100 times faster than it would be before, because they just change how the data dictionary works. Not that you should do that, you shouldn't, but it's faster now. So the DDL, the DDL stands for Data Definition Language, consists on data dictionary updates, because you can update the data dictionary, storage engine operations, like I'm changing from InnoDB to MyISM, that kind of stuff, and binary log writes, mostly. And now, I told you, you can have atomic DDL. Who here try job table 1, comma table 2, comma table 3, and table 2 stopped, and your job table 1 and table 3 is still there, and 2 got corrupted. That doesn't happen anymore. Either all changes happen, or none of them is going to happen. It doesn't mean it is transactional, that the creation of table is transactional or not. It means they are guarantee you atomicity within the database. And let me show you the other bits that I was here. Users now can have roles. So if you created a grant for someone, you can multiply that without having to go user by user creating. You can add columns instantaneously without having to wait 2 days to add a column to your database. Cats instead of FIFO, as I said before. You can do a JSON partial update which means you don't need to deserialize the JSON, do the change, and then serialize again. You can do directly on the database. If the new version of, if the new data is smaller or equal to the JSON that was already there. And they have better geospatial support for indexing and generated columns, and better UUID support. And you can use MySQL now as NoSQL if you wish so. They release what they call MySQL Shell, or the XDev APIs, I forgot to put it in here, where you can add, you can also use that with PHP and Node.js. So, thank you.